The sun does many different things. It doesn't just emit light and help you grow plants. It doesn't just provide infrared radiation, otherwise known as radiative heat energy on planet Earth. It also creates and ejects massive plasma filaments, like the one you see in this image. We'll cover it. We've got a decline in solar activity, a decline in solar sunspot number, and some comets to show you on the coronagraph imagery. That and lots more on today's Daily Space Weather. This is the past 24 hours from SDO, featuring ionized helium and ionized iron to help to create some contrast there in the roiling, chaotic environment of the solar corona. Here's a zoom out to the equatorial view. Again, a lot of plasma filaments on the Earth-facing portion of the solar disk. The likelihood of coronal mass ejections remains nearly 100%. And it looks like the most active region is actually this region here that is setting in the southwest. So that'll be something to keep an eye on in the coming 24 hours. And when I say eye on, well, the pun was intentional. There's a full disk view for you. These are the same wavelengths here, 24 hours. And let's take a look at what's going on in terms of closer up views of these filaments. You can see one hanging out by the north heliographic polar region. That's known as a crown prominence. And that could form into another one of these solar polar vortices, basically at any moment. For now, it looks like it's as stable as it's been. We've also got, like I said, the most active region there is the southwestern sunspot there. Also a huge filament just behind that. Pretty much put up that 24-hour video just for the aesthetics. Also got some filamentary material hanging out, suspended by magnetic fields defying gravity by the south heliographic polar region. And there's also the just ionized helium view by itself. Let's take a look at sunspots briefly. We have seen a little bit of degradation here, so sunspot number should be dropping today. There is one sunspot group that hasn't gotten a name yet. It'll be down here in the southeast. It'll be known as 3333. That's yesterday plus today, SDO continuum. And here's SDO colorized magnetogram. Again, a little bit of degradation since yesterday in terms of sunspots. And let's take a brief moment to see what's going on planet Earth. One of the things that's going on planet Earth is Kilauea's erupting. So check this out. This will not disappoint. From the Two Pineapples channel. And this has great audio as well. We'll play a moment of that. The sounds and sights of the spatter cone above the Halema Uma'u lava lake there at Kilauea. It is pretty sweet imagery there. Shout out to the Two Pineapples channel. And let's see what else is erupting here around planet Earth. Abico starts out the list. Looks like an uptick at Abico there. It's a 15,000-foot ash plume, flight level 150. Unknown volcanic ash cloud there from Mayan, which we showed an amazing image of yesterday. It has a growing lava dome right at the summit. Bagana now on the list. On Bougainville Island at Papua New Guinea now exploding, flight level 100. It's a 10,000-foot ash plume there as Bagana bursts onto the scene. Ibu exploding, flight level 080 over Ibu. As it explodes, it's an 8,000-foot ash plume. Krakatau, 7,000-foot ash plume over the Sunda Strait. Dacono, producing a 7,000-foot ash plume. Flight level 210 over central Mexico from Popocatépetl. It's a 21,000-foot ash plume. No volcanic emissions from Fuego. However, Nevado del Ruiz possibly emitting some volcanic ash. Sangay exploding. Flight level 200 over Ecuador from Sangay. Flight level 150 over Ecuador from Ravenador. It's a 15,000-foot ash plume and 20,000-foot ash plume over Sabancaya in Peru as it explodes. It's a flight level 240. Largest quake in the past 24 hours came in while we were doing show prep. Yeah, it's an over 6 magnitude here near Japan. The likelihood of it producing a tsunami is basically 0%, which is why we didn't send out any emails to the Smash team at smashomash.com/Smash team. If you like email alerts about such things, well, you could join at the bronze level. It'll cost you exactly $0 per month. The best value, because it includes additional content, would be the gold annual paid up subscription. smashomash.com/Smash team. Anyway, there's the location of that quake. It was a 6.2 just south of Sapporo there. It was at a depth of over 100 kilometers, which is why we do not anticipate any tsunami activity. We'll cite the other quakes that are over a 5 magnitude. And I certainly do see one odd one here. So yesterday was quite calm as far as quakes. And then early this morning, at 0:38, there was a 5.0 at South Africa. Not a common place for a quake there at all. 5.0 at South Africa, striking at 0:38 this morning. And then about 2.5 hours later, the Kuril Islands saw a 5.2, which is northeast of that 6.2 at Japan. Indonesia had a 5.0 at 6:51 Universal Time this morning, and then that 6.2 at Japan. So today, much more seismically active than yesterday. And remember, folks, any earthquake can be a foreshock. Now, getting back to space, let's cut back to our 304 angstroms wavelength. And how about some more imagery of that plasma reorientation happening there around the northeastern limb? There's some pretty sweet imagery for you. And that filament remains intact at the moment. Don't expect it to stay that way. These things have a tendency of either collapsing, reorienting, or becoming coronal mass ejections. We've also got the 171 angstroms wavelength. Once again, that's the past 24 hours from SDO. It's our house favorite wavelength. And here we've added 211 angstroms and zoomed in once again at the northeastern limb. And here we've zoomed out. That's 211 plus 171 angstroms. And let's get back to some data. Yeah, data. The 10.7 centimeter radio flux is currently at 161 solar flux units. A dip from yesterday, having just a couple days ago gone back over 170. That 1-year graph there depicts a radio flux as per that black line. The red line up there is a sunspot number. Space Weather Enthusiast dashboard forecasting a little bit of geomagnetic unrest late tonight and early tomorrow morning. There you can see June 11th, June 12th there, featuring some geomagnetic unrest. I imagine it's from the coronal hole high-speed wind stream that we're seeing. Let's take a look at NASA's model of that. There is the inner planet view from the Integrated Space Weather Analysis Center Events tab. It depicts the inner planets, and check out that green box over on the left image there. That's the Parker Solar Probe, making another solar dive as it gets closer and closer and faster with each one. And as you can see from NASA's data here, no Earth-directed coronal mass ejections are currently indicated. And it looks like this coronal hole high-speed stream is pretty weak. We'll get to the data on that here momentarily. First Earth's magnetic moment from space for the past 4 hours, and we have had a geomagnetic intensification. It was short-lived and pretty weak. But like we said a couple of days ago, any signal bringing us up from 275 kilometers per second solar wind speed will be significant. Let's let that play all the way through there. Keep in mind these videos are streamed live and not edited to get them onto your screen as quickly as possible. So this depicts magnetohydrodynamic pressure. It's Earth's magnetic moment from space out to about 12 Earth diameters. Somewhere around there is about the size of Earth's magnetosphere. Here's Earth's magnetic moment from the ground for the past 4 hours. And again, a minor uptick here in the solar wind has produced a little bit of geomagnetic effects. They have been short-lived and fairly weak, but any sort of an uptick shows up as a significant signal when the solar wind has been as slow and diffuse as it's been. KP index currently only at 2.33 there. KP 2.33 is the planetary K index, an average of global geomagnetism. And here you can see this coronal hole high-speed stream impact right around when we forecasted it a couple of days ago. You can see this uptick in the solar wind density. And then the density drops down and the speed comes up, as is typical with coronal hole high-speed streams. Also a solid signal here for the high-speed portion, depicted as an increase in plasma temperature and also variations in the magnetic field. So if you look at the field strength here, the field strength only reached out to about 15 nanotesla, and we didn't have extended periods of negative BZ, but now we're going into a negative BZ, so we could see this turn into geomagnetic unrest rather quickly here, as we've got a BT of 11 and a BZ of negative 9. That negative BZ has a tendency to induce more current into the Earth system. So if everything stays the same, if the field keeps increasing and the BZ stays negative and strong like that, we could see geomagnetic unrest kick up here relatively soon. Current conditions for the speed and density of the solar wind are 387 kilometers per second for the solar wind speed. Solar wind density here about 6 3/4 protons per cubic centimeter. Next, our GOES magnetometers. Surprisingly smooth there for a coronal hole high-speed stream impact. And again, it has been a weak coronal hole high-speed stream impact, which is why you're not seeing a big effect on the GOES magnetometer. Next, we'll take a look at the heliospheric current sheet. And Earth has just recently, in the past 6 hours or so, snapped into the South Pole current sheet, as you can see depicted here in red. South Pole current sheet over here, North Pole current sheet over here. Let's take a look at our line of sight field plot next. Solar B field depicted here in blue, North Polar field in green, South Polar field in red, and of course the gong magnetogram there in grayscale. So still lots of magnetism on the Earth-facing portion of the solar disk, just a minor downtick here in solar activity since yesterday. And let's take a look at the coronal hole line of sight plot. We've got significant South Pole-oriented coronal holes rotating in here. What do you say we have a look at those? Here's the last image. You can see the B field there. That's the sector boundary crossing. Right around here, Earth moves from a North Pole current sheet to a South Pole current sheet. So let's go back to our 171 plus 211 angstroms wavelengths. There you have that, and let's drop the 171 angstroms. And there you can see great definition of those South Pole-oriented coronal holes. Those coronal holes rotating in here in the eastern limb, that one there is transequatorial. So we can expect a significant uptick from that in about 4 days. So there'll be another coronal hole high-speed stream on the way. This one should be a lot stronger, as transequatorial coronal holes are the kind that are the most geo-effective. So let's continue on here. The next thing to cover would be sunspots. So here's the Integrated Space Weather Analysis Center's solar flare probability and solar flare scoreboard. And, well, there's one sunspot that ought to be on the scoreboard right up here. That should be 3333. Besides that, again, we've had like a minor degradation since yesterday. So a little bit of a reduction in sunspot number may be coming. Sunspots have shrunk and, well, they've frankly become less magnetically complex. However, we still do have multiple groups there approaching the southwestern limb. That increases the likelihood of large flares over there. And let's cut to sunspots. Here's our SDO Continuum 24-hour video. And again, you may see a little degradation there. It's pretty minor. Keep in mind the magnetic environment can change with basically no warning. The most likely place for a large flare, in my opinion, is now down here in the southwestern limb, as we've got a recently submitted science paper about solar flare anisotropy. So congratulations to Eugene Bagashov on that. It's just been submitted, so that should be interesting to see what happens next in terms of the peer review process. Let's take a look at energetic particles. No spikes in the proton flux there, therefore no solar energetic particle events. And only minor flaring here. So the background level of flaring remains in the upper B level. It's like a B8 background X-ray flux. We've only seen some C-class intensifications. That looks like the biggest flare in the past 24, which was a C5.55. And how about if we cut to the SDO 131 angstroms wavelength? And that C-class flare, that's C5.5. Well, it definitely came from the southern hemisphere. I believe it was this group here. And if I'm incorrect, let us know in the comments. It's really not that big of an issue. And let's move on to inform our viewers of what's going on overhead. So this is what's happening overhead at Lehigh Valley. If you want to make your own star chart, head to skyandtelescope.org. You've got the sun there. It's cloudy, so it's not going to be sunny, but we've got the moon and Saturn high in the sky there. If you're up before dawn, you might see that. Also Jupiter. Sometimes the fourth brightest object and sometimes the fifth brightest object, depending on the location of Mars. Anyway, that's the current situation overhead, Lehigh Valley, Pennsylvania, where we are located. And here is the solar system forecast for the next week as we approach new moon. It looks like new moon will indeed be in 1 week on the 18th. Once again, shout out to all my reverse werewolves. Get ready to sleep well and be happy, productive, functional members of society who are not nuts. Next, coronagraphs, and we've got some fascinating imagery here on some coronagraphs, including a comet, which you can actually see rolling in right down here in the southwest. Right there, you can see that comet moving in. And that thing was already broken up by the time it showed up on the imagery. So that's a little bit of a highlight of the day there. Those are yesterday's coronagraph images. Here are 34 more frames from today. Let's also show the view from Soho-Lascaux C2 and C3. You can see that comet right there on Soho-Lascaux C3. And right at the end of the video, I believe it shows up. There it is. There's the leading edge of it. There's actually multiple fragments there. So here is if you look at, you see here, you see the main nucleus. Ahead of that, you can see right in here another object taking almost the exact same trajectory, an indication that that comet was already breaking up when it appeared on the imagery. Not sure if it's going to be visible from stereo A or not, but let's take a look at stereo A as well. Oftentimes these things do appear on stereo A. I don't see any reason for it not to, as it looked like a pretty significant comet there of pretty significant brightness. Now, of course, over here you can easily see it right there. See if it shows up on stereo A at all. Should be a pretty similar location there. Not seeing it on stereo A for whatever reason. And let's take a look at our custom videos, as they are totally sweet. Here you'll see that comet dropping in. You see that preliminary fragment, which looks like, again, that gives us some indication that that thing was already breaking up when it showed up on the imagery. And if we zoom out one step here you'll see some great images of that comet. Again, probably already broken up by the time it showed up on the blue portion there. That's the Soho Lasco C3 coronagraph. And it looks like a cosmic ray strike on the aperture right here, right as that video ends. Just another example of great timing there, or perhaps divine providence. Looking like a cosmic ray impact there. Anyway, those are some pretty sweet coronagraphs, wouldn't you say? And that's one of those many examples of when you discover things that you weren't looking for. Here's the last 24 hours in SDO 193 angstroms by itself. And let's move on, as it's almost time for bonus features. Yes, bonus features. Before we do that, filaments. Yeah, filaments. There are a lot of them on the Earth-facing portion of the solar disk. Once again, these do often lead to coronal mass ejections. Sometimes they collapse and don't eject. But look at all the filaments. There's like a dozen. I mean, let's briefly count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At least 10 filaments on the Earth-facing portion of the solar disk. Some of those may be counting as, you may want to count those as more than one. If you want to name filaments after living people, make sure you join us over on Twitter. We're all over the internet at Smash-O-Mash. I think we've recently reached like 400 followers on Twitter or something like that. And if you think censorship has been fixed by Elon, please enter into reality. Elon has left the censorship in place on Twitter. Don't be a pathetic and sycophantic fanboy. It's embarrassing. So here's the past couple of hours from the GOES SUVI. That's ionized helium. What we love about the GOES SUVI, which is why we stream it regularly all day long on the Twitch channel, is because it shows the extended corona here. So it's great at showing coronal mass ejections as they happen. And there certainly is a lot of capability for plasma instability here. I mean, look at all of those filaments. There are plenty of active regions. And yeah, it's, I think the most likely place to see a major CME is from up here in the northeast. There is an inordinate amount of plasma hanging out up there. But hey, lots of places here are featuring in unstable plasma indeed. So let's move to our bonus feature segment, starting with satellite charging hazards. We've got some minor ones here over Mexico, the western portion of North America there, and the eastern portion of the Pacific Ocean. Those surface charging hazards are caused by low energy electrons building up on the outsides of spacecraft. They are minor charging hazards. Don't expect major communications breakdowns from those. Next, the GOES electron flux here, which is probably a little bit lower than the forecast model. That's the past 3 days of the relativistic electrons there, measured by the GOES 16 and GOES 18 using radiography at the F layer of the ionosphere. So there is the 1-year graph of the relativistic electrons. Again, they're measured at the F layer of the ionosphere. And here's the forecast model. And the observation was a little bit higher electron flux than anticipated, which means this one will probably be down here. Anyway, that's the forecast model by NOAA for the relativistic electrons. Again, they're measured at the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with these distances and atmospheric layer temperatures, chemical concentrations, and electromagnetic radiation penetration. Here is the F flare in vibrational frequency, megahertz, which is millions of vibrations per second. We're not expecting any major anomalies from this coronal hole high-speed stream. It is quite minor. It's quite weak. And here's the anomalygram showing anomaly in megahertz from a 30-day median. And you may note this area down here, especially if you're a new viewer. If you are a new viewer, congratulations on realizing the channel exists. You may notice this area down here. That is the South Atlantic anomaly. That's where you see those high and low frequency anomalies bordering each other all the time almost. The South Atlantic anomaly is over the South American continent and is probably a feature of a geomagnetic excursion. Do we think the poles are going to flip? Not at all, as we don't see any quadrupoles. Although we do see some weak spots in the magnetosphere, which the biggest one is over here, and there's also a smaller one around equatorial Africa. So that's sort of the weakest area of Earth's magnetosphere. It is super well evidenced by these ionosphere videos, courtesy of Australian Government Bureau of Meteorology. And let's bring up the latest image and show each. So there's 11 o'clock universal time ionogram and 11 o'clock universal time anomalygram. We also show the total electron content daily on the channel because it shows the most likely places for GPS errors, and it also gives us insight into what's going on with things like Earth's Van Allen belts. After all, your GPS satellite has to communicate through about 12,500 miles of things, which includes the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. Those free electrons can refract the signal. They do refract the signal. And here are the most likely places to see that signal refraction. And we do have significant GPS errors expected. So that's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Again, it depicts the free electrons from about 12,500 miles of altitude down to your GPS handset. And again, a lot of free electrons here are out of place, a common feature of coronal hole high-speed stream impacts. We'll also show the U.S. anomaly from the 10-day average. And we are seeing some anomalies here with the signal data. So it looks like a lot of stations were on and off there. We're also seeing some high electron content anomalies over the central part of the U.S. So let's actually rock this back for once. So here are some, you see some anomalies there over the central U.S. Here are some around the Cascadia fault zone, central U.S. There's some over the western U.S. Let's just let that play through. I can't really move it very smoothly. Those are the total electron content difference from the 10-day average, the 10-day anomaly for the electron contents. And we'll close out the space weather section of the video with the latest intensity gram. And we show the refresh on purpose. Again, these videos are streamed live originally, and we don't edit them to get them onto your screens as quickly as possible. Plus, I just like the live format better. It's just simply better. So again, this sunspot down here, that's 3333. That'll get a name today, or there'll be hell to pay. I'll send an email to somebody and say, why haven't you named that sunspot? Let's move to meteorology. Yes, meteorology. I learned about 15 years ago that it was way too easy to forecast the weather in shockingly intricate detail. So that's one of the features of a time trial specialist, as that is my specialty in the sport of cycling, going very fast by myself against the clock over very specific distances. And if you're not able to forecast the weather, you're not going to be as good of a time trialist as you could be if you can forecast the weather. So anyway, that's part of the reason why I got into space weather, because, well, forecasting Earth weather is way too easy. It's also for the sake of cosmology, which we'll talk about at a later time. This is the mean sea level pressure, and this is something interesting that you may understand if you understand atmospheric physics. Check it out. It's the Drake Passage, one of the weirdest places in the world where the Pacific Ocean and the Atlantic Ocean try to reach thermal and pressure equilibrium. What's going on now is you've got the world's largest low pressure system just to the east of that, and then you've got a huge high pressure system here just to the west of it, which you may think is forcing water through the Drake Passage in this direction, right? Because you've got a pressing down over here and you've got a lifting up over here, so water should try to flow from west to east, right? So let's look at the currents. And indeed, there are currents flowing in that direction. You think it's a coincidence? No, that's a function of understanding thermodynamics, static equilibrium, hydrodynamics, all of these sorts of things. And congratulations to all of my viewers who do. You might be able to forecast the weather as you understand things like gravity, pressure, precipitation, humidity, and so on, temperature. Anyway, that is the world's largest and most significant low pressure zone, by the way. Look at the high pressure over Antarctica. That is a very, very large low there in the southern Atlantic Ocean around where it borders the Southern Ocean. No other pressure systems in the world even come close to that. That is a huge low pressure. So let's get to our regularly scheduled wind maps here. This is the surface wind scenario for the eastern world. This is the jet stream scenario for the eastern world. Central world. There are the jet streams of the central world. What the heck? Oh, I've got currents turned on. I'm sorry. Let me cut back. There is the eastern world's jet streams. I was still showing ocean currents. And there are the surface winds. Surface winds of the central world here. Jet streams depicted here. And the jet streams of the west. Now returning to the U.S. As forecast yesterday, there still is a strong anticyclone rotating clockwise here over central Canada. Again, the jet stream is going to become more coherent here in the coming days. We'll show a forecast for that momentarily. There are the surface winds of the western world. And you can indeed see this powerful anticyclone down here rotating counterclockwise as they do in the southern hemisphere. Now we've got some strong systems here showing up over the U.S. Let me just refresh that to get a good satellite image there, as there is a low pressure forming over the southwestern portion of Missouri right now. It's actually moved a little bit toward Mountain Home. It's slowly making its way to the east, and it's going to make a turn to the northeast. So this low is, right now it's going this way, it's going to go that way, toward Indianapolis. And that's your satellite map from windy.com. Let's briefly zoom out and show the globe view. There you go. There's the full planet view. I don't know why it looks so... It doesn't like the poles. It doesn't like the Arctic. There you get that great animation of the entire planet's cloud cover. The windy.com satellite. It's pretty sweet. There's a mobile app. It doesn't cost you a dime. Just like the bronze membership at smashomash.com/smash team. Next, clouds and fog over the Americas. That is the shortwave radiation map, part of the NASA GOES interactive weather satellite suite. It depicts 3.9 micrometer infrared radiation to show you clouds and fog when it's too dark for the visible satellite. That's what's going on over this side of the planet. And here are your weather alerts from weather.gov. We'll briefly show you the key. It looks like some hydrologic outlook there. Some hydrologic outlook or flood warning maybe? Hydrologic outlook it looks like for northern Nevada. As the snowmelt continues, and let's take a moment to look at that. The state of snow. Yes, snow. as we've had a 7th consecutive record snow season for the Northern Hemisphere. The snow water equivalent is finally returning to normal. So let's look at the 3 major indicators here. The snow mass balance, it's actually popped back out of the 30-year standard deviation, which is the blue shaded region there. Looks like a little bit of snow must have happened someplace, probably like Greenland or Canada. The snow extent is actually at the high end there of the plus or minus 1 standard deviation range indicated by the area in between the blue lines. And last but not least, the snow water equivalent still well outside the 1 standard deviation zone. As epic snowmelt continues, you can expect it to continue. And let's take a look at the jet stream forecast. So here is the GFS 72-hour forecast for the 250 millibar winds. And you can see the jet stream will be reestablished here over the southern portion of the U.S. That will make things a little bit more normal, as some of those weather systems will actually get pushed from west to east as they usually do. Again, it's a 72-hour GFS 250 millibar wind forecast. Here's a GFS 72-hour temperature anomaly forecast in degrees Celsius. You can see most of the country here expecting unseasonably cool temperatures for the coming 3 days. You can expect that low pressure there to move up toward the northeast. And it'll be more evident on this imagery, the pressure and precipitation forecast for the same period and the same model, the 72-hour GFS model. Here you can see that low. It's going to actually it's going to wait about a day and then make that turn to the northeast there and go across Ohio and western PA. And that should be good for Pennsylvania, as there is an extreme drought through the entire state of Pennsylvania. So that's the current situation. Here is our lightning station for the past about 10 hours. Some heavy lightning there around Texas and Louisiana has since subsided. And let's see what's going on with current terrestrial strikes. They continue north of the Mediterranean. Do we have any in the U.S.? I see some. Southern Indiana. Hey, Louisville. There is a thunderstorm to your north. Yeah, Louisville. Scottsburg, Salem, there's thunder rolling in at the moment. So that's our real-time lightning map. We like to show it to show where the teeth of the storms are. It's brought to you by blitzachtung.org, lightningmaps.org. Check it out next time you hear thunder. And the real thunder comes from smashomash.com/smash team. So these videos are brought to you at massive personal risk and expense by Smash staff and I, but also by the charitable, not yet charitable contributions, but the contributions from members of the Smash team at smashomash.com/smash team. So thanks to the gold and silver members especially for increasing the probability these videos will remain existent, publicly visible, and free for all to view. If you'd like additional content, become a member of the Smash team. You can even get a @smashomash.com email address or complimentary merch, for example, if you join at the gold level for the email addresses or the gold annual paid-up subscription for the complimentary merch. It's like getting 4 months free. There is also a paid promotion in this video. One of them is the Hemp Lucid shop, so check that out. Links below the video to that, as well as on the homepage at smashomash.com. When you're doing your Hemp Lucid shopping, know that I endorse the Focus Mushroom Gummies, as I became a pro cyclist in 1999 on the cross-country mountain bike. And I use the Focus Mushroom Gummies, but there's lots of other products here that I'm willing to endorse as well. Enter the promo code SMASHOMASH on checkout to save 10%. Again, you can find links below this video in the description, as well as on our homepage at smashomash.com. So do your Hemp Lucid shopping through our link. Enter the promo code SMASHOMASH. That'll save you 10% on your checkout. Thanks to everybody who's picked up products. Some spectacularly great products there from Hemp Lucid. Again, links on the homepage at smashomash.com. And welcome to the Neo Renaissance. Did you know that we're in the process of starting a nonprofit organization? Yeah, it's going to be a thing. And we're also building an observatory this year. So we are way, way behind in our funding. Thanks to everybody who has increased the probability of this becoming a thing. Again, links on the homepage to that. You can also find a link to the Amazon shop, and today's featured product is from the Redbubble shop, which is linked there as well. The Smash-O merch. If you click on that, you'll find the Redbubble shop. Today's featured product is MAXA. Yeah, MAXA, which stands for Make Astronomy and Cosmology Science Again. So when I took college astronomy back in the mid-1990s, I realized that, well, first of all, I thought there was going to be in-depth information about heliophysics, and there wasn't at all. It was evident that we did not know what's going on with the sun back then. I realized back then that it's a huge hole in the realm of cosmology, and, well, that's why I'm back to write a paper that explains the mechanism that underlies the solar sunspot cycles. That will be the most important Nature paper in hundreds of years once it passes peer review, and we're quite confident that it will, as I've been trying to disprove my own theory for a long time, longer than I care to even remember, and all I find is more data that backs it up and zero data that refutes it. So we're in the process of making astronomy and cosmology science again. Perhaps help out the channel by picking up some merch from the merch shop, or if you'd like the sunglasses that I'm currently wearing, yeah, you can find them on the Amazon shop. That's also linked below the video and on the homepage at smashomash.com under the Spaceware playlist. And if you haven't seen the Instagram page, you can find fitness, lifestyle, and diet posts on there. If you're into that sort of thing, make sure you visit our other videos. We've got playlists that have nothing to do with space weather. There is even a cosmology playlist there that has like 250 videos about cosmology. So thanks to our new subscribers. Again, congratulations on realizing the channel exists. We're frankly surprised, although I don't see any valid reason why the channel should be censored. I mean, you think that YouTube would want to promote the advancement of cosmology and heliophysics and so on. So anyway, thanks to our new subscribers in any case. And let's close this mother out with the U.S. Doppler radar. We'll briefly zoom out here as there is some precipitation there striking Alaska. And there is the lower 48. Here is clouds and fog. It's the NASA GOES Interactive Weather Satellite Suite shortwave radiation map. And there you can see that low there making its way across Missouri toward Illinois and Tennessee and Kentucky. It'll be even more obvious on the water vapor map. You can see that counterclockwise rotation starting to set up there. And it looks like clear skies over most of the Gulf of Mexico there, as there is a lot of dry air over the Gulf. Anyway, here's your recap. U.S. Doppler radar. Clouds and fog. And there is water vapor. And here is me going back to the bunker because all of this information about what's going on overhead in the sky and so on is very scary. I'm scared and spooked of space, so get rid of those scary pink letters, and I am headed back to the beach. I mean, bunker. So see you soon. I may pop my head out later and make another video. You never know. In the meantime, may that solar wind be at your back. Whoa.